Ready? All right. I love the sound of my own voice. So let's go ahead and get started, everybody. If you're interested in Node.js on Azure, come on in, have a seat, and we'll get started. Don't get up. Oh, I'm too loud. Well, luckily, Joe will be doing most of the talk.
Yeah.
All right. So welcome, everybody. I'm Dan Shaw, founder and chief evangelist of NodeSource, and joined today with Joe Doyle, solution architect manager. And we're going to be sharing some of the work that we've been doing to bring NodeSource NSolid to the Azure platform. Very excited to share that with you today.
So getting started, what is Node.js? It is kind of gaining popularity, but not everybody knows what it is, not everybody's using it. So Node.js is a runtime that allows you to use JavaScript on the server side to create your applications. Oftentimes, especially community here, are used to using C# or F# to write your applications, but Node.js allows you to do evented I/O with JavaScript. So who are we? Who is NodeSource? NodeSource is the Node.js company. You may be asking yourself, what does that mean? Node.js itself is an open source project. There is a Node Foundation, which manages and governs the open source project. So when we say we are the Node company, we're the other half to that. If you download the Node.js binaries today, you're using our binaries that we built in our infrastructure. On staff, we have the most core contributors on the Node.js project, as well as 14 other members of staff that are part of various working groups and other aspects of the Node.js Foundation and community. NodeSource itself, again, we are the commercial offering for Node.js. We have several products in our product line. First and foremost, we have our NSolid runtime. It's a hardened, secure Node.js runtime that is a drop-in replacement for the open source version. We have our NodeSource certified modules. This is a way to help protect yourself against the 410,000 NPM modules that exist in the ecosystem, to give you some guidelines as to what are high-quality modules, which are ones we should look to use inside of our applications, and what are the ones we should stay away from. In addition to our normal product offerings, we do offer full enterprise support for Node.js. You're deploying your applications to production. These are critical runtime applications. You need a phone number to call, and that's NodeSource. So why are we here today? And really, this slide, I feel, really encapsulates that point. Microsoft and Node.js really go together. Microsoft has put a tremendous amount of work towards improving the status of Node.js on all platforms, including Windows. And they're also doing a lot of work to make sure that the foundation itself is healthy and vibrant.
And honestly, if it weren't for Microsoft, we wouldn't be where we are today with the popularity of the platform. Early on, Microsoft contributed to the Node.js project and brought us cross-platform and really helped make Node what it is today.
Yeah. So we start talking about Azure, right? Azure's a great platform to run Node, and really the reason why that is because of that continued support from Microsoft for the Node project. So when we talk about cloud-native Node.js, really Azure covers all the bases for any way you'd want to run Node.js inside of Azure. We have a way to map that. So going straight from Linux VM running Node to working with containers using Docker. Or if you're looking to go all the way with containers using a full orchestration like something like Kubernetes, allowing you to get the most control over your Node.js applications and scale it very easily on the Azure platform. But let's dive a little bit deeper into NodeSource NSolid runtime, because it's really kind of the best matching with Node.js and Azure, and even Kubernetes itself. So we talked a little bit about what it was, but really, NSolid is meant for larger customers that want to use Node.js, but are looking for a little bit more than what the open source platform can provide. So companies that are in financial industries that have higher regulations, healthcare concerns around private information, they need a little bit more out of the Node.js platform than just what the open source community is willing to accept into the runtime. So NSolid allows us to add those features in and help those customers out. Some of the key features of NSolid are real-time security vulnerability scanning, making sure that the modules that you're running inside of your application in production are vulnerability-free. we have the ability to visualize the health of your Node.js processes. You can see how all of your processes are behaving in real time. We'll be able to easily identify outliers as your application is running. And finally, and almost most importantly, is the ability to troubleshoot and gather valuable debugging information from your applications in production while they're running, without having to shut down the application, tell Node to capture that debugging information, and then try to reproduce it. Instead, we can capture all that information with a click of a button, allowing your developers to easily get insight into what's going wrong with your Node.js applications. So really, a lot of what we strive to, this is a little bit of an eye chart, we apologize for that, but a lot of the goals that we strive to do is really build upon the success of Node.js. Node.js is a fantastic platform. It's been proven time and time again across all the Fortune 500 companies that it is ready for enterprise load. But NSolid looks to help make that even better by meeting those needs that those enterprise customers have. So now to some of the good stuff. NSolid on Azure. NodeSource has partnered with Microsoft to add NSolid to the Azure Marketplace, giving single-click opportunity to launch NSolid into your own Azure accounts and get these valuable resources when you're trying to run your own Node.js applications on Azure. So what we're going to do is we're actually going to jump in and dive into a live demo and show off some of this stuff, because unfortunately, it's kind of hard to talk about getting good performance information. It just kind of sounds like sales and marketing talk. So let's actually dive in, see real world, how are we using NSolid on Azure, put some applications under load, and show where NSolid really can shine. So starting off, we have our standard Azure dashboard. Really, this is the center of everything you're doing on Azure, just like everything else. For our demo environment today, we're using several of the container-based resources from Azure. We have a container registry set up where our demo application has been pushed into. We are going to be running on Docker and Kubernetes. We have already set up a Kubernetes cluster using ACS. We also have agent pools. So we have 3 nodes set up in Azure that are going to run our application. So setting up Kubernetes inside of Azure is actually a really fantastic experience. If you try to do it manually by hand, there's a lot of steps. There's a lot of things you need to try to figure out how things line up. But when you actually go through and launch Azure, just like everything else inside the dashboard, fill in some information about what's the name of your cluster, what's the name of the resources we should be using, and then what subscription should we go to. It's really straightforward. Couple fill in the blanks and say next. The added value that makes Azure shine even more, in my opinion, is this page we have up here. Microsoft has done an amazing job scripting the ability to auto-wire up the client side of Kubernetes to easily allow you and your development team to interact with your Kubernetes cluster without having to jump through any of the crazy hoops of trying to open up the correct ports, find the right mappings to get inside the right nodes inside of your cluster. Instead, we just have a couple command line tools that will automatically download our Kubernetes control tool. It will automatically set up our authentication, and then we're ready to go and basically talk to our Kubernetes cluster. For the sake of time, we've kind of bypassed all those steps, but what we're able to do is kind of highlight and show our cluster. So kube control is our command line utility. We can say get nodes. Basically, this will get us our status of our Kubernetes cluster. So as we can see here, we have one master instance that is basically in charge of all the scheduling. And then we have 3 of our agents that are actually going to be responsible for running our applications. So as we can see here, I'm running on my local Mac, and we're talking through the Kubernetes tool into the cloud, querying our Kubernetes dashboard. To get to our dashboard, Kubernetes has another fantastic bit called kube control proxy. What this does is this handles all the heavy lifting of trying to figure out how, as a developer, do I get back into my cluster and actually see the UI. The last thing you really want to do is open up your Kubernetes cluster out to the internet, allowing folks to do some very nasty and potentially very expensive things to your cluster. So what we're able to do is launch this proxy command, and then we can jump into our UI and jump right into our Kubernetes dashboard. One of the great things about Azure with the Kubernetes platform is this is the vanilla Kubernetes dashboard. So any prior knowledge you may have using Kubernetes anywhere else will automatically translate to running Kubernetes on Azure, allowing your team to instantly be successful, or run Kubernetes across multiple clouds if you're looking for the ultimate in high availability. So what are we seeing here? We talked about our nodes. We can see the running instances. These map to our VMs that are running inside of Azure. They're already set up with Docker installed, and Kubernetes has done all the hard work with putting all of its internal agents onto those nodes for us so that they are now completely ready to run our application and scale our application as needed. When it comes to NSolid, one of the things we've done is we've created a namespace. And again, for the sake of time, we've already gone through and installed the NSolid components into our cluster. And essentially what we have is we have our storage unit for NSolid, which is collecting that data that we talked about for managing the visualization of our processes. We have a web console that lets us introspect into our Node.js applications. And then, of course, we have a pod that is running Nginx to allow us to secure that web interface to the outside world, adding SSL and password authentication. One of the things that we've done with our partnership with Microsoft is all of this setup is available open source, online, and GitHub. You simply just need to follow our instructions for using our predefined Kubernetes service definitions and using the kube control command line tool to walk through and automate standing all of this up. One of the awesome things about Kubernetes is once you've defined these common services through a YAML file, they're easily repeatedly deployed without having to worry about the details of it every single time. Inside of Kubernetes, one of the ways that we can interact with the outside world is through the definition of services. So as we see here, our Nginx proxy has been given an IP address. So this is our IP address that allows us to jump back into NSolid in a protected way to view what's going on inside our storage. When we go ahead and jump into that, we see this is our NSolid console. Now, I didn't have to do anything to configure this. Again, we just follow our steps on our GitHub repo. And what we see here is we have one simple application called build demo, nice and easy, but we're only running one process. If we go through and highlight that, we'll see our process is pretty boring. So what we're going to do is we're going to pretend that we just posted onto Hacker News, and our cool little startup is about to get pounded unexpectedly by traffic that we might not be ready for. So what we're seeing inside our NSolid console is the x-axis is representing the percentage of CPU used by our Node.js process. The y-axis is the percentage of memory, and each dot represents the individual process that's running our application on the NSolid runtime. So as you notice, we're getting more and more popular. It's starting to be 9 a.m. East Coast time, and people are hammering our little site, and our CPU is starting to pick up more and more and more. So that's no bueno. What are we going to do? Fortunately, with running Kubernetes on Azure, it is super simple to be able to scale up our commands. We can simply use the Kubernetes control tool to say, hey, I'm running one instance of my application today. I need to run 16. I think 16 will handle the load for Hacker News. So we issue that command to Kubernetes. Kubernetes is going to say, hey, inside of our cluster, do we have room to run 16 instances of this app? Fortunately, we planned ahead. We have 3 nodes. So those 3 nodes are now starting to get multiple instances of our demo app. There's a load balancer that's built into Kubernetes automatically, and we see right away we start to handle the load. One of the great things about NSolid is as our instances come up and down, as your dynamic use of Kubernetes may lend to, those processes will automatically appear and disappear inside of the NSolid console, letting you really see what's going on inside of your cluster. So as you notice, our 16 instances have spun up. We've handled the load. Now, instead of having our CPU on our one machine being pegged around 80, 90%, we now have a nice healthy cluster responding to our traffic in an appropriate way. We actually get a little interactive with some of our processes. We can go select one of our dots, and we want to see a little bit more information about that process itself. We get some of the basic stats about that process. We can look inside of Node itself, get a look inside of the memory that V8 has allocated for my JavaScript inside my application. We can also see some of the async activity. What are we doing as far as network calls? What file reads are we doing? One of the great things about Node.js is its async nature. So one of the, this graph really kind of helps to illustrate what's going on behind the scenes under the hood of Node.js as far as all that async I/O. In addition, one of the most powerful features of NSolid is the debugging information. So right now, we're running under load 16 nodes. I've selected one of them, and we're going to go ahead and we're going to create a CPU profile. So what this is doing is this is telling Node.js, using the NSolid runtime, yes, to go ahead and capture a profile of our CPU usage in our Node.js application. Now, the best part of this is that you can do this same thing with the open source Node.js. The problem is you have to stop the process, turn a flag on, put the process back into production, back under load. While it's doing that, it's writing files to your local server or inside of your container. Then when you think you have enough, you have to undo that all and then put your process back in. So with NSolid, you click the button, we automatically visualize it inside of the browser. You get a timeline to show you how much of CPU time is actually being consumed here. And then we have an interactive flame graph where we can walk through and actually examine where inside of our application we're using the most CPU. So if we go through and select that, we can see a visualization of the stack trace that got us there inside of our application, and then how much CPU time that's actually using. So the good news for our application now is we actually don't have a CPU problem anymore, right? We've scaled out to 16 processes. The thing using the most CPU is actually the Express web framework itself, which I'm pretty confident is relatively optimized. And our Node.js application is running as it should be. So as we go through and we want to take a look at what happened on the Kubernetes side real quick, if we go back to our default namespace, we can see our deployments, and we can see that now, sure enough, Kubernetes has given us 16 instances of our process. We can see some of the metrics about the application as a whole, because in Kubernetes, it doesn't really matter the fact if we have 1 or 16, what's the health in general of our process. And finally, when it comes down to it, you want a little bit more information, Kubernetes also lets us dive down a little bit deeper to see each of those 16 processes running spread across all of the nodes in our Kubernetes cluster. So that is our introduction for today. Basically, if you're using Node.js in production, we would love to talk to you, get information about how you're using Node. If you have any pain points, such as memory leaks or CPU problems inside of Node.js, NSolid is definitely a tool that can help assist that, and we would love to have a conversation with you.